Hi there, welcome to this video. My name's John. I provide mathematics tuition for A-level maths, A-level further maths, including 6th-term examination papers and mathematics admissions tests. One welcome to this video where we're going to take a look at a problem that I've selected from the 1987 Step 3 paper to have a look at, and it's question number 5 from that particular paper that we're going to take a look at. So this question involves something called modular arithmetic, which typically you might not come across on your A-level maths and A-level further maths courses at present. Nevertheless, modular arithmetic is not, in principle, it's very straightforward to understand. Obviously, as with anything, its theory can be developed and so on. It can get very involved beyond a certain point, but in principle, it's straightforward to understand the principle of modular arithmetic. If you are going on to university, or you're planning on going on to university to do maths, then if you're doing any number theory, you'll almost certainly come across modular arithmetic. So I'll just give a quick rundown of what modular arithmetic involves without going into too much detail. So let's say we take numbers, so we can take numbers modulo 2, numbers modulo 3, numbers modulo 4, and so on and so forth. So let's take, for example, numbers modulo 6. Okay, so modulo 6. So what you might see sometimes is, for example, the numbers modulo 6, you might see them as, the numbers modulo 6 as 0. I've written 1 now, and I meant to write 0. Should have written 0. 0, 1, 2, 3, 4, 5. However, what you might sometimes see, not always though, is you might see a little subscript of a 6 next to these numbers to distinguish them from the normal 0, 1, 2, 3, 4, and 5 that we're all familiar with. So the little subscript 6, all it's doing is just indicating that, for example, if we take this 0 sub 6, that this is the 0 in modulo 6 arithmetic, in the system of modulo 6 arithmetic. Sometimes you'll see that, sometimes you won't. Sometimes you might see square brackets with a 6 or something like that, or you might even see square brackets modulo 6. There's all kinds of different ways that it's going to be represented. I tend to, if I really need to, I'll probably just write the mod 6 if we're working in modulo 6. Actually, it's modulo 50 that we're going to be working in this. So how does modulo 6 work? Well, if we take a number, just a normal number, so we're not talking about modulo 6 this time, and we think, let's say we take 15. Okay, what I do is I divide 15 by 6. But I do division with remainder. Okay, so I don't calculate the decimal or something like that, or the rational number 15 over 6. It's division with remainder. So if I divide 15 by 6, I feel like I'm going back to like year 6 or something like that here. 15 divided by 6 is going to be 6, 12, so it's going to be 2, remainder 3, right? 2 remainder 3. So what that means is that in modulo 6, 15 modulo 6 is equal to 3 modulo 6. Okay, so we're looking at the remainder. Where do I get the 3 from? It's the remainder. So 15 is, in modulo 6, is equal to the remainder of 15 when divided by 6 in modulo 6. Okay, so let's say we take 25. What's 25 modulo 6? Well, 25 divided by 6, division with remainder, is going to be 6, 12, 18, 24, remainder 1. So it's going to be equal to 1 modulo 6. Okay. So modular arithmetic is effectively counting all of the numbers that have the same remainder when divided by 6, we count as being the same thing. We put them into an equivalence, what's called an equivalence class. Okay, so 15 and 3 would be in the same equivalence class. Okay, so that means that you can get things like 6 is equal to 0, which might look a little bit... So, I mean, 15 equals 3 is a strange thing to write, but remember, it's 15 modulo 6 is equal to 3 modulo 6. We're not saying that 15 is equal to 3. We're not saying that 6 is equal to 0. What we're saying is that the remainder, when 6 is divided by 6, is equal to 0. In the same way, when we say 15 modulo 6 is equal to 3 modulo 6, what we're saying is that the remainder, when 15 is divided by 6, is equal to the remainder when 3 is divided by 6, which is 3. Okay, and that's the idea behind modular arithmetic. Now, you don't need to worry too much about this, really. You don't need to know massive detail about modular arithmetic to attack this problem. Question number 5 that we're going to be taking a look at. Let me just get rid of some of this stuff, clear some space. Okay, so I was actually really surprised about this problem, problem number 5, because of all of the step problems that I've ever attempted, this was probably the easiest problem, the easiest step problem. It took me, I think, all of 3 minutes to figure out this. That's not meant to be a flex, by the way. It's just, I couldn't believe it myself, just how easy the problem was. And although when I say it was easy, I think sometimes there's a lot of luck involved in if you do manage to solve a problem quickly, sometimes it's just good luck that you've had, that you've made the right kinds of observations as you've gone through, and I think that's what happened here. So anyway, let's have a look at the problem. It should be a nice short video. Let me have a drink of coffee first. Okay, so it's an unusual problem in some respects. I could see how a problem such as this could be a bit disconcerting sometimes to some people, because it's very different to the kinds of problems that you would typically encounter on your normal maths and A-level further maths textbook questions and things like that. Anyway, let's get on with it. So, a secret message consists of the numbers 1, 3, 7, 23, 24, 37, 39, 43, 43, 43, 45, 47, arranged in some order as A1, A2 up to A12. The message is encoded as B1, B2 up to B12, with 0 less than or equal to B sub j, less than or equal to 49. And then we've got two relations, equations, effectively. B2j is equal to, and this is modular, in modulo 50, plus n0 plus j modulo 50, and b2j plus 1 is equal to a2j plus 1 plus n1 plus j, again modulo 50. For some integers n sub 0 and n sub 1. If the coded message is 35, 27, 2, 36, 15, 35, 8, 40, 40, 37, 24, 48, find the original message and explaining your method carefully. Okay, I think that's kind of goes without saying, explaining your method, because arguably it would be theoretically possible for you to just recombine the number, to reorder the numbers 1, 3, 7, 23, 24, 37 and so on, just randomly, and if enough people do that, then likelihood is that somebody's going to be right just by pure chance. So that's not really what we're after. That's not a strategy that's going to be terribly effective. We need something that's going to be a bit more reliable. Okay, so what I did to solve this, the first thing that I did, which probably actually took up the most amount of time for me, was actually writing out the following. So B1, using these relationships here, which again I'll leave a link in the description to this video so you can download this for yourself, and I'll put the question up on the screen so you can see it. So we've got B1. So in this case, we're in this case B2j plus 1, where j is equal to 0. Okay, so this is therefore going to be equal to, and I'm just going to use equals rather than identical, the 3 equals symbol, whatever you want to call it. Okay, so that's going to be equal to A1 plus N1 plus 0. Okay, so we do have a plus 0. I'm not going to bother writing that. And this is modulo 50, right? And I'm probably not going to keep writing modulo 50 all the time. I'll write it for this one, but it's going to be fairly well understood that we're dealing with modulo 50 for these calculations. So B2, so this is this case now, where j is equal to 1. So this is going to be A2 plus n0, n sub 0 plus 1. Oh, I've actually missed off the most important bit here. So that's the first one is going to be equal to 35. So that's the first number in the code, the coded sequence of numbers, the coded message. This is going to be equal to 27. And again, we're dealing modulo 50. B3 is equal to A3 plus N1 plus 1, and that's equal to 2. So it is just literally simply a case of writing all of these out, and it's a bit of a pain, but it's easy enough. You know, there's not really much thinking that you have to do at this to do this. Just equal to 36. B5 is equal to 50. A5 plus N1 plus 2, which is equal to 15. B6 is A6 plus N0 plus 3. And okay, I'll move over here now. So B7, which is A7 plus N1 plus 3, and that's going to be equal to 8. Plus N0. So all I'm doing here is just recognizing that in the coded message, B1 is equal to 35, B2 is equal to 27, B3 is equal to 2, and so on and so forth. I'm just gradually working through. B9 is A9 plus N1 plus 4, which is 40. B10, like I say, this was the thing that actually took the most time of the 3, maybe 4 minutes that it took me to solve this particular problem. This is what took the most time. Finally, B12 is equal to A12 plus n naught plus 6, and that's equal to 48. Okay. Scroll down a little bit. Okay, so now we've got all those established, these equations established. Where do we go from here? Well, what I did next was I singled out, what was it, B2, B4, B6, B8, B10, and B12. Okay. So because these all involve n sub naught. Okay. So what I was hoping to do was to try to figure out a value of n sub naught. I had no idea, by the way, how this was going to go, and it's entirely normal when you're solving a problem to only have sometimes kind of vague ideas about what you want to try to do, but it's just important that you try things out. So what I did was I wrote, for example, that A2, I'm not going to write all of these out, I hope. A2 plus N0 is equal to 26. Okay. A4 plus N0 is equal to 34. A6, actually I think I am going to have to write these out, plus N0 is equal to 32. So all I'm doing here is, let's say I take this equation B6. I actually don't need the B6. But the equation corresponding to B6, which is A6 plus N0 plus 3 equals 35. All I'm doing is just subtracting 3 from each side of this. And that's giving me this equation here. A6 plus N0 is equal to 32. So I'm just doing that for all of the even subscripts. I don't know why I chose to do to concentrate on even subscripts. I just did. It was just something that I did. Okay, and then we've got A8 is equal to A8 plus N0. No, get rid of that. Plus N0 is equal to 36, and then something happened that really caught my attention. A10 plus N0 is equal to 32. Plus N0 is equal to 42. Okay, so what did I do then? Well, I focused on this A6 plus N0 equals 32 and A10 plus N0 equals 32. Because what this implies is that A6 is equal to A10, at least modulo 50. Okay? So we could have, for example, just to give a bit of an example, A6 could be equal to 3 and A10 might be equal to 53. Okay? Because they're the same number modulo 50. But we don't... Actually, all of the numbers in the original message, they're all less than 50. Okay? So I don't need to worry about really extracting the dividing by 50 and finding the remainder and stuff like that. I don't need to worry about stuff like that. So when I write here that A6 is equal to A10, actually it means literally A6 is equal to A10. Well, that can only happen in one way. If I look at the original list of numbers that I've got, that means that there must be a repeated number somewhere in the original message, uncoded message. Well, that means that these two must be equal to 43, because that's the only number that is repeated. So we've got 1, 3, 7, 23, 24, 37, 39, 43, 43, 43, 45, 47. So that gives me the values of, and this is where I couldn't believe my luck really, that it was so straightforward. I almost had to pinch myself. But I almost didn't believe it until right at the end of the problem that it was going to be that straightforward. I thought I must have made a mistake or something like that. But anyway, I kind of followed it through, because this gives you the value effectively of n0, right? So if we look now at a6 plus n0 equals 32, we've got that 43 plus n0 is equal to 32. Now I do need to worry about modulo 50. So I need to think, what can I add to 43 to get 32 in modulo 50? Well, if I add 7, 43 plus 7, that will give me 0 modulo 50. So plus 32, that will give me 32 modulo 50. So if I add, so 43 plus 39 is equal to 32 in modulo 50. So that means that n0 is equal to 39. Okay. So once you've got that n0, then the values of A2, A4, A8, A12, they just fall out. Okay. Let me see what I got. So let's take the equation A2. A2 plus n0, which is 39, equals 26. Okay, I've got to figure out what do I add to 39 to get 26 modulo 50. Well, 39 plus 11 plus 26. 39 plus 11, that takes me back to 0. And then add another 26, so it's going to be 37. So A2 is equal to 37. And all I was doing as I was going through these was just making sure that these numbers actually did show up in the original list of numbers. So we get A2 equals 37. We've got A6 and A10 equal to 43. The other numbers you figure out in exactly the same way. A4 is equal to 45. A8 is equal to 47, and A12 is equal to 3. Okay. So we're not done yet because we need to look at the odd subscripts. And this is where I was originally thinking, things really have to step up here. This has been easy. I've chosen the nice, easy subscripts to deal with. This is where it gets difficult, right? So, okay, we get a similar set of equations. A1 plus N1 is equal to 35. Again, modulo 50. A3 plus N1 is equal to 1. A5 plus N1 is equal to 13. A7 plus N1 is equal to 5. A9 plus N1 is equal to 36, and A11 plus N1 is equal to 19. Now, we don't get any of the repetitions. We shouldn't expect that, actually. We shouldn't expect any repetitions in this case. But what we do get is that A1 plus N1 is equal to 35, and A9 plus N1 is equal to 36. So what that means is that A1 plus 1 is equal to A9. Didn't want it to do that. So in my original list of numbers, are there any numbers which are there any successive numbers, successive integers? Yes, 23 and 24, for example. So that gives me that A1 is equal to 23. It gives me that A9 is equal to 24. So once I know these, then I can figure out the value of N1, for example. So A1, which is equal to 23, 23 plus n1 is equal to 35. Again, modulo 50, which means that n1 must be equal to 12. Okay, well, a3 plus 12 equals 1 modulo 50. That means that a3 must be equal to 39. Again, modulo 50, right? Always in the back of our minds is this modulo 50. I'm not writing it every time because it'd get tedious. So we've got a1, a9, we've got a3, and values for a... What have we got left? a5. a5 is equal to 1. a7 is equal to 43. And a11 is equal to 7. So then we've got all of the numbers from the original list of numbers, 1, 3, 7, 23, 24, and so on. We've got them all accounted for. So now the original message, the original unencoded message, well, just put the values in order. So it's going to be 23. What did I get for A2? 23, 37. Let me write it out. The original message is A1, which is 23, A2, which is 37, A3, which is 39, A4, 45, A5, 1, 6, A7, A8, A9, A10, A11, and A12. Okay, so that's the original message. It's as simple as that. Okay, nice, easy problem. It's actually taken me a lot longer to explain it than to actually do it in the first place. But hopefully you enjoyed that. If you are interested in finding out more about modular arithmetic, then go ahead and do your own bit of research on it. It's not something that I'm necessarily an expert in. I did a little bit of number theory when I was at university, but I didn't do a massive amount of number theory. But I remember that modular arithmetic did come up, and it's an important thing. Okay, so if you've got any questions about anything that I've done in this video, please let me know in the comments section. Please show your support for this channel by hitting the subscribe button, hitting the like button, and sharing this video with anybody that you think might benefit from it. I do make these videos for free. I don't make any money from them, so I will continue to make these videos as long as I am able to do so. And while I've got the support for doing so. What I really want to do is to put as many videos out as I can to help you guys prepare for your exams in the best way possible. If there's anything that you would like to see, if there's any way that you think that I could be helping you better, let me know. I'm just at the minute I'm just making videos. I don't necessarily know exactly what people want. So if you guys can let me know, what do you want to see in videos? What kind of topics do you want me to cover? How do you want me to go about things? Let me know. So that I can help you in the best way possible. But on that note, I will say thank you for watching, and I will see you in the next video. Thanks a lot.